To determine if a nail has been driven through a wire without energizing the circuit, several testing methods can be employed. Firstly, conduct a thorough visual inspection. Carefully examine the wire along its entire length. Look for any visible signs of damage, such as punctures, tears, or deformations. Note any bent or misshapen areas, as these could indicate the presence of a nail or other foreign object piercing the wire. Secondly, use a multimeter to perform a continuity test. Set the multimeter to the continuity testing setting. This is typically indicated by a diode symbol or an audible beep symbol. Touch one probe of the multimeter to one end of the wire in question. Then touch the other probe to the opposite end of the same wire. If the multimeter beeps audibly, or if the display indicates a low resistance value close to 0 ohms, it indicates that the wire is continuous. This suggests that there is an uninterrupted path for electrical current to flow through the wire. A continuous wire is likely not punctured by a nail, as a nail would typically sever the conductive path. However, if the multimeter does not beep, or if it displays a high resistance value indicating an open circuit, it suggests that the wire is discontinuous. This could be due to a nail having severed the wire's conductive path. Thirdly, perform a voltage drop test. This test will require a power source. Connect a voltmeter in parallel with the wire to be tested. Paralleling a voltmeter means connecting the voltmeter's leads to the same 2 points in the wire. Apply a small direct current voltage, for example, 9 volts, to the wire. Observe the voltage reading on the voltmeter. If the wire is intact and not punctured, the voltmeter should display the applied voltage, or very close to it. This indicates that there is minimal voltage drop along the wire. However, if the wire is punctured or damaged, there will be a significant voltage drop across the punctured section. The voltmeter will display a voltage significantly lower than the applied voltage. A substantial voltage drop suggests that the wire is compromised and likely punctured. Fourthly, conduct an insulation resistance test. This test requires an insulation resistance tester, also known as a megameter or maker. This device applies a high direct current voltage to the wire and measures the resistance between the conductor and the insulation surrounding it. Connect one lead of the insulation resistance tester to the wire's conductor. Connect the other lead to the wire's insulation or to a grounded metallic surface near the wire. Apply the test voltage, as specified by the insulation resistance tester's instructions, typically ranging from 500 volts to 1000 volts. Observe the resistance reading on the tester. A high insulation resistance value, typically in the megohms or gigohms range, indicates that the insulation is intact and providing adequate protection. However, a low insulation resistance value suggests that the insulation is compromised. This could be due to a puncture or damage caused by a nail, allowing current to leak through the insulation. Fifthly, an inductance test may be used, particularly if the wire is part of an inductive circuit, such as a coil or inductor. Use an inductance meter, also known as an LCR meter, to measure the inductance of the wire or the inductive component. Connect the inductance meter to the terminals of the wire or component, following the meter's instructions. Measure and record the inductance value. Compare the measured inductance value to the expected value for that wire or component. A significant decrease in inductance compared to the expected value could indicate a puncture or damage to the wire. A nail puncture can alter the wire's geometry and magnetic properties, leading to a reduction in inductance. Safety precautions are paramount when performing these tests. Always ensure that the circuit is completely isolated from any power source before commencing any testing procedure. This prevents accidental electric shock and ensures personal safety. Use appropriate personal protective equipment, including insulated gloves and safety glasses. Gloves protect against potential electrical hazards, while safety glasses protect the eyes from debris or arc flashes. If you are unsure or uncomfortable performing these tests, it is strongly recommended to seek professional help from a qualified electrician. Electricians have the necessary training, experience, and equipment to safely and accurately assess the condition of electrical wiring. An electrician can identify and resolve any potential hazards, ensuring the safety and reliability of the electrical system. Keep in mind that these tests are diagnostic tools to help identify potential issues. Visual inspection offers a first-hand look at the wire's condition, revealing obvious signs of damage. A multimeter continuity test quickly confirms whether the wire's conductive path is intact, indicating breaks or severances. A voltage drop test, when conducted with a low voltage source, can highlight compromised sections of the wire due to punctures or damage. An insulation resistance test assesses the integrity of the wire's insulation, revealing any weaknesses or breaches that could lead to electrical leakage. An inductance test is particularly useful for wires that are part of inductive circuits, identifying changes in inductance that may indicate damage. By employing these methods and adhering to safety precautions, a determination can be made if a nail has been driven through a wire without the need to energize the circuit, ensuring a safe and thorough assessment. Remember, a systematic approach, combined with the appropriate tools and safety measures, provides the best means of detecting and addressing potential wiring issues. This process ensures a safe working environment and maintains the integrity of the electrical system. Furthermore, understanding the underlying principles of each test enhances diagnostic accuracy. Continuity testing relies on the principle that a continuous wire offers a low resistance path for current flow. Voltage drop testing is based on the concept that a damaged wire will exhibit an increased resistance, resulting in a noticeable voltage drop across the affected area. Insulation resistance testing assesses the ability of the wire's insulation to prevent current leakage, with a high resistance indicating good insulation and a low resistance indicating compromised insulation. Inductance testing measures the wire's ability to store energy in a magnetic field, with a decrease in inductance potentially indicating physical damage or alterations to the wire's geometry. In practice, it may be beneficial to perform multiple tests to confirm findings and gain a more comprehensive understanding of the wire's condition. For example, a visual inspection might reveal a suspected puncture, which can then be confirmed by a continuity test and an insulation resistance test. The combination of test results provides a more robust assessment than relying on a single test alone. Moreover, it is crucial to document all test results, including the date, time, and specific observations made during the inspection. This documentation serves as a valuable record for future reference and can be helpful in tracking the progression of any identified issues. Accurate record keeping also aids in communication with other professionals, such as electricians or building inspectors, who may need to review the findings. In addition to the testing methods described above, there are other advanced techniques that can be used to assess the condition of electrical wiring. These include time domain reflectometry, or TDR, and infrared thermography. TDR is a technique that sends a pulse of energy down the wire and analyzes the reflections to identify fault or changes in impedance. Infrared thermography uses an infrared camera to detect heat signatures in the wire, which can indicate areas of excessive current flow or resistance due to damage or corrosion. These advanced techniques require specialized equipment and training but can provide valuable insights into the condition of electrical wiring. In conclusion, assessing the condition of electrical wiring for nail punctures without energizing the circuit requires a systematic approach that combines visual inspection, continuity testing, voltage drop testing, insulation resistance testing, and inductance testing. By following safety precautions and documenting all findings, a comprehensive assessment of the wire's condition can be made, ensuring a safe and reliable electrical system. If any doubts or uncertainties arise, seeking professional help from a qualified electrician is always recommended. These tests are instrumental in ensuring safety. One must isolate the circuit before proceeding to prevent any electrical hazards. Secondly, use appropriate safety gear such as insulated gloves and eye protection is a must. Thirdly, if any abnormalities or damages are noticed during visual inspection, make sure to accurately document them. Fourthly, when performing a continuity test, ensure that the multimeter is set to the appropriate setting and that the probes are making good contact with the wire ends. Fifthly, during a voltage drop test, use a low voltage source to prevent any potential damage to the wire or equipment. Sixthly, when conducting an insulation resistance test, follow the manufacturer's instructions for the insulation resistance tester and apply the appropriate test voltage. Seventhly, when performing an inductance test, use an inductance meter that is calibrated and appropriate for the type of wire or component being tested. Eighthly, if any test results are inconclusive or raise concerns, seek the assistance of a qualified electrician for further evaluation. Ninthly, always err on the side of caution and prioritize safety when working with electrical wiring. Tenthly, regular inspections and maintenance of electrical wiring can help prevent nail punctures and other types of damage. Performing a thorough visual inspection is a foundational step in identifying potential nail punctures in electrical wires. This process involves carefully examining the wire's surface for any signs of damage, such as punctures, tears, or deformations. It is crucial to pay attention to areas where the wire may have been exposed to mechanical stress or where nails or screws may have been driven into the wall or ceiling. Using a flashlight can help illuminate hard-to-see areas and highlight any irregularities in the wire's surface. When performing a visual inspection, look for telltale signs of nail punctures, such as small holes, indentations, or raised areas on the wire's insulation. These punctures may be accompanied by discoloration or cracking of the insulation material. In some cases, the nail may still be embedded in the wire, making it easier to identify the puncture location. However, it is important to exercise caution when approaching any suspected nail punctures, as the wire may be energized. Always ensure that the circuit is de-energized before attempting to touch or manipulate the wire. In addition to visually inspecting the wire's surface, it is also important to examine the surrounding area for any evidence of nail punctures. This may include looking for nails or screws that have been driven into the wall or ceiling near the wire. If any nails or screws are found, they should be carefully removed and inspected for signs of contact with the wire. Even if the nail or screw does not appear to have directly punctured the wire, it may have damaged the insulation or caused other forms of damage. The continuity test is a simple but effective method for determining whether a wire has been severed or damaged by a nail puncture. This test involves using a multimeter to measure the electrical continuity between 2 points on the wire. If the wire is intact, the multimeter will indicate a low resistance, indicating that electricity can flow freely between the 2 points. However, if the wire has been severed or damaged by a nail puncture, the multimeter will indicate a high resistance, indicating that electricity cannot flow between the 2 points. To perform a continuity test, first set the multimeter to the continuity testing setting. This setting is typically indicated by a diode symbol or an audible beep symbol. Next, touch one probe of the multimeter to one end of the wire in question. Then touch the other probe to the opposite end of the same wire. If the multimeter beeps audibly or if the display indicates a low resistance value, it indicates that the wire is continuous and likely not punctured by a nail. However, if the multimeter does not beep or if it displays a high resistance value, it suggests that the wire is discontinuous and may have been punctured by a nail. It is important to note that a continuity test can only detect complete breaks in the wire. If the nail puncture has only partially damaged the wire or the insulation, the continuity test may not reveal any problems. In such cases, other testing methods, such as a voltage drop test or an insulation resistance test, may be necessary to detect the damage. The voltage drop test is a more sensitive method for detecting nail punctures than the continuity test. This test involves applying a small voltage to the wire and measuring the voltage drop across a section of the wire. If the wire is intact, the voltage drop will be minimal. However, if the wire has been punctured by a nail, the voltage drop will be significantly higher due to the increased resistance at the puncture location. To perform a voltage drop test, first, connect a voltmeter in parallel with the section of the wire to be tested. Paralleling a voltmeter means connecting the voltmeter's leads to the same 2 points on the wire. Next, apply a small voltage such as 9 volts direct current to the wire. This can be done using a battery or a low voltage power supply. Then, observe the voltage reading on the voltmeter. If the wire is intact and not punctured, the voltmeter should display the applied voltage or very close to it. This indicates that there is minimal voltage drop along the wire. However, if the wire is punctured or damaged, there will be a significant voltage drop across the punctured section. The voltmeter will display a voltage significantly lower than the applied voltage. A substantial voltage drop suggests that the wire is compromised and likely punctured. The magnitude of the voltage drop will depend on the severity of the puncture and the amount of current flowing through the wire. A larger voltage drop indicates a more severe puncture. The insulation resistance test is a method for assessing the integrity of the wire's insulation. This test involves using an insulation resistance tester to measure the resistance between the conductor and the insulation surrounding it. If the insulation is intact, the insulation resistance tester will indicate a high resistance, indicating that the insulation is providing adequate protection. However, if the insulation has been punctured by a nail or otherwise damaged, the insulation resistance tester will indicate a low resistance, indicating that the insulation has been compromised. To perform an insulation resistance test, first connect one lead of the insulation resistance tester to the wire's conductor. Then, connect the other lead to the wire's insulation or to a grounded metallic surface near the wire. Next, apply the test voltage as specified by the insulation resistance tester's instructions. The test voltage typically ranges from 500 volts to 1000 volts, depending on the tester and the type of wire being tested. Then, observe the resistance reading on the tester. A high insulation resistance value, typically in the megohms or gigohms range, indicates that the insulation is intact and providing adequate protection. However, a low insulation resistance value suggests that the insulation is compromised. This could be due to a puncture or damage caused by a nail, allowing current to leak through the insulation. The insulation resistance test is a more sensitive method for detecting insulation damage than a visual inspection or a continuity test. It can detect even small punctures or cracks in the insulation that may not be visible to the naked eye. The inductance test is a method for assessing the condition of electrical wires that are part of an inductive circuit, such as a coil or inductor. This test involves using an inductance meter to measure the inductance of the wire or the inductive component. If the wire or component is intact, the inductance meter will indicate a specific inductance value, depending on the design of the circuit. However, if the wire has been punctured by a nail or otherwise damaged, the inductance meter may indicate a different inductance value, indicating that the wire or component has been compromised. To perform an inductance test, first connect the inductance meter to the terminals of the wire or component, following the meter's instructions. Next, measure and record the inductance value. Then, compare the measured inductance value to the expected value for that wire or component. The expected inductance value may be specified in the circuit diagram or in the component's datasheet. A significant decrease in inductance compared to the expected value could indicate a puncture or damage to the wire. A nail puncture can alter the wire's geometry and magnetic properties, leading to a reduction in inductance. It is important to note that the inductance test is only applicable to wires that are part of an inductive circuit. It cannot be used to test wires that are simply used for conducting electricity. In conclusion, assessing the condition of electrical wiring for nail punctures without energizing the circuit requires a systematic approach that combines visual inspection, continuity testing, voltage drop testing, insulation resistance testing, and inductance testing. By following safety precautions and documenting all findings, a comprehensive assessment of the wire's condition can be made, ensuring a safe and reliable electrical system.